Llwyn Onn was originally constructed in 1940 and is now at the end of its lifetime, and that's the reason we planned for it to be rebuilt in 2013. The main point that we had to look at very early on was redundancy. We wanted a plant that if we had failure, we could still continue to supply treated water to the population. With the design that the software systems integrator Tycon came out with, we've managed to achieve that.
Well, the biggest challenge was obviously the level of redundancy Dee Valley Water were looking for in their system. We looked at a variety of systems, but we have worked with Mitsubishi in the past. Mitsubishi in this instance fitted the bill quite well because the actual QMPRH system that they've built up offered all the levels of redundancy and was very flexible in the approach that we required. But the Q series as a whole is very flexible from the outset. It basically suited the application to a T.
The treatment works is capable of treating 47,500 metres cubed of water per day for Wrexham and the surrounding areas. It's the principal treatment works for Dee Valley Water in the Wrexham area. We had a tight budget, but at the same time we've managed to implement a few things that will save us in the long term operationally. We've got a recycle facility that we never had before, which means any water from washing in filters or from desludging the DAF can be recycled to the head of the works. We have the rapid gravity filters, that's for removing manganese out of the raw water.
The control system itself is built up of a QMPRH, which is obviously the 2 CPU racks, and then in the actual I/O is split across 3 I/O racks. The 3 I/O racks have got redundant power supplies on, and 3 I/O racks were chosen because of the fact that the plant can be split into 3 quite equally. Each I/O rack's got 4 Profibus networks on. 1 goes round the MCC, the other 3 move out into the field. The field networks all terminate in panels such as the one over there, which is an I/O panel, where all the level devices and the flow meters, etc. are connected to. The PLC's got 2 processors, so if either processor fails, it immediately switches over to the second one. That's if a power supply fails, a network card or anything in the rack that's associated with the processor fails, it immediately switches over and there's no interruption whatsoever to the plant. We can interrogate the PLC system remotely. There's a VPN link into the control system which we can access via a secure link, and that allows you to interrogate anything that's basically connected to the Ethernet or to the Profibus networks. So we can actually dial in directly to the SCADA and view what the operators are seeing.
The PLC has been functioning perfectly well since commissioning. We've had no issues with it at all. It's doing the job we wanted it to do.